Welcome. As you can see here, we've been given a table of values. That is, we've been given a table that tells us f and g evaluated at 0, 1, and 2. And we have also been told what the first derivative of f and g are evaluated at 0, 1, and 2. Finally, we're given that h is this composition of functions and told to find the first derivative of h evaluated at 1. So this requires applying the chain rule. The first derivative of h is equal to the derivative of f, and rather than put an x here, we need to keep the inner function g intact, then multiply by the derivative of g. Now we can use our table to figure out what g of x is and 8. But we didn't want this formula. We really just wanted to find the derivative of h evaluated at 1. So that's f of g of 1. If you notice, I just replaced this x value, or both of these, with a 1. And so this one will also have a 1. Now, I need to figure out what g of 1 is. G of 1, according to my table, if we look down this column and this row, we see that g of 1 is equal to 0 here at the intersection. Furthermore, we need to find out what the first derivative of g evaluated at 1 is. So now we look at this last column and this middle row, and their intersection here is 6. So the first derivative of g evaluated at 1 is equal to 6. Now I can replace some things. That is, I'm going to write f prime, and instead of writing g of 1 again, I'm going to replace that with the value of g of 1, which is 0, and multiply that. And again, instead of just writing the g prime of 1, I'm going to replace that with this 6. Okay, so now I need to use this table to figure out the first derivative of f evaluated at 0. So that would be this column. So that would be this column here and this row, and these intersect at 3. So the first derivative of f evaluated at 0 is 3. So h prime of 1 is just equal to 3 times 6, which is 18. I hope this video has been helpful.